Welcome to homework.
We're asked to construct a finite state machine for a combination lock that contains numbers 1 through 40 and that opens only when the correct combination, in this case 10 right, 8 second left, 37 right, is entered. And we're told that each input is going to be a triple consisting of the number, the direction of the turn, and the number of times the lock is turned in that direction. So as we're already told, input is a triple consisting of a number, direction of the turn, and the number of times the lock is turned in that direction. So let's consider 4 different states: S0, S1, S2, and S3. So S0 is going to be our start state, and S0 is going to represent the fact, that all 3 numbers still have to be entered correctly. Now S1 is going to represent the fact that 10 right, the first in the combination, was entered correctly. But 8 second left and 37 right still needs to be entered. Sorry, 8 second left and 37 right. Now, S2 is going to represent that 10 right and 8 second left were entered correctly. And finally, S3 will represent that the lock is open. In other words, that we've entered all three of the combination correctly. Now, let D represent all the inputs different from the other inputs that are known to lead to another state. So example, D is going to contain, if we're at state S0, well, say we enter 11 right. Well, then we're not going to move to state S1, S2, or S3. We're going to stay in S0. And now let L represent the left and R represent right. And suppose that the wrong combination is entered. Then always return to state 0. Suppose that the first combination, 10 right, is entered at any state. Then we'll always move back to S1. Suppose that 8 second left is the input at S1. Then we're going to move from state S1 to state S2. And now suppose that 37 right is the input at S2. Then we're going to move from S2 to S3.